Welcome back to the deep dive. This is where we take that dense foundational knowledge, the stuff that really makes you a pro, and we try to carve it into something you can actually use.
Exactly.
Today, we're diving into a topic that honestly can feel a little dry, test tools. But here's the thing, if you ignore this, you're basically ignoring the entire infrastructure of modern software quality.
It's absolutely foundational, you're right. I mean, think about it. In the larger context of the ISTQB syllabus, we've talked about the what and the how, the processes, the design techniques, the risk analysis.
All the brain work.
All the brain work. And Chapter 6, which is our focus today, is what connects all that theory to, well, to reality. It's about how technology, how specific tools let all that intellectual activity actually happen at scale.
So tools are the engine.
They're the engine. They move testing from this world of just, purely manual checking into the realm of efficient, data-driven, and this is key repeatable quality assurance.
And that's our mission today. We're going to explore the sheer diversity of these tools because it's not just one thing. They cover the entire software development lifecycle, the SDLC.
Right.
And here's the really crucial part. We are going to dissect test automation. We have to look past the marketing hype. What are the genuine strategic benefits? And maybe even more importantly, what are the huge, often crippling risks that so many organizations just seem to underestimate time and time again?
And it's important for you, the listener, to realize that even though this chapter might seem short in the syllabus, I think it's addressed only about 20 minutes of instruction time.
20 minutes, yeah.
It's covering knowledge that is absolutely core. We're talking K1, which is recall, and K2, which is explain. You need to not just know what these tools are, but why they matter strategically.
Why they exist.
Why they exist. They're what allow us to hit key business goals, like, effectively reporting on test progress and the actual quality of the system back to the stakeholders who are paying for it all.
Okay, so a quick preview of our key takeaways. First, you need to get your head around the fact that tool support is vast. It is not just a fancy script runner. It covers management, static analysis, infrastructure, everything.
And second, and this is the big one, you have to grasp the duality of automation. It is tremendously powerful, yes, but that power demands realistic planning, rigorous maintenance, and above all, critical human oversight. You can't just set it and forget it.
Okay, let's unpack this. The source material makes it crystal clear that tooling supports and facilitates pretty much all test activities. This isn't about one tool for one job.
No, it's an ecosystem.
It's an ecosystem. So I want to start by mapping these different tools directly to the test process we've already discussed, sort of moving through the life cycle from start to finish.
That's a great way to structure it. That segmentation is critical. If you think about the SDLC in phases, planning, analysis, coding, all the way to execution and deployment, well, there are tools designed to make each one of those phases more efficient or more systematic or just more measurable.
So where do we begin?
We begin at the highest level, the oversight layer.
Which brings us to tools for management and process efficiency. Okay, so if these tools don't actually run any tests, what is their strategic value? Why do they matter so much to a business?
Their value is all about organization, auditability, and communication. We're talking primarily about what are called test management tools.
Okay.
Their function is explicitly defined in the syllabus as increasing the efficiency of the whole test process. They let you centrally manage the entire software development lifecycle. That means tracking requirements, traceability.
This is huge.
It's massive. It also means organizing your test cases and your test suites, logging and managing defects, so bug tracking and handling configuration items. Like, which version of the software was this test actually run against?
So if I'm a test manager on a huge project, maybe 500 requirements, a couple thousand test cases, and a constant stream of bugs coming in, this tool is what stops it all from descending into just pure chaos.
Chaos prevention is a perfect way to put it. That is a huge benefit. But the real expert insight goes a little deeper. These tools transform raw data into actionable intelligence.
Okay, what does that mean in practice?
It means a test management tool aggregates all your raw test results, a pass, a fail, detailed log files, whatever, and it pulls in all the defect logs and it turns them into meaningful metrics. It gives you the statistics, the graphs, the dashboards that management actually needs to see.
So it's a translation layer.
It is. It lets the team effectively report on test progress and quality, which fulfills that key business outcome we mentioned. It gives stakeholders confidence, and in, say, a regulated industry like finance or healthcare, it provides the essential auditable trail that shows exactly when and how every quality check was performed. Without these tools, all your reporting is just subjective and wildly inconsistent.
That really flips the narrative, doesn't it? It goes from, ugh, these are annoying tracking tools I have to update, to these are critical strategic communication and audit tools.
Absolutely. So now, let's shift. Let's go way left in the process.
Ugh.
Before a single line of dynamic code is even run, we have a whole category of tools focused on analysis and prevention.
Okay, so the goal here is finding bugs when they're cheapest to fix, right? During the design or coding phase.
That's it exactly. And this is where we see static testing tools come into play. Now, we've defined static testing before as, analyzing a work product without actually executing the code.
Right. Looking at the blueprint, not running the engine.
Perfect analogy. Can you elaborate a bit on the different kinds of tools here? Because there's a pretty wide spectrum.
Yes, there is. These tools can support manual reviews for sure, but their real power is in automated static analysis. And, on the simpler end of the spectrum, and the sources surprisingly point this out, you have things like spelling checkers.
A spell checker.
Yeah, a spell checker or a readability tool. You apply it to a requirements document or a test plan or a user manual. It's checking for quality characteristics like clarity and accuracy against, established linguistic rules.
Okay, I have to ask. A spell checker seems almost comically basic compared to some of the stuff we're going to talk about. Why does the source material even bother to include something so simple under the banner of a test tool?
It's a great question, and I think it's there to illustrate a really fundamental concept. Anything that helps verify the quality of a work product is a test tool. Think about it. A typo in a requirements document can lead directly to a defect in the code because the developer built the wrong thing.
Okay, that makes sense.
Or a style checker that makes a test procedure easier to read, ensures that the human who's executing that test doesn't misunderstand a critical step. But you're right. The real power comes from the much more complex tools that we apply directly at the source code.
Right, the static analysis engines.
Exactly. These tools are incredibly sophisticated. They're checking for things like adherence to coding standards, they're calculating maintainability metrics, they're doing deep data flow analysis and control flow analysis.
And security vulnerabilities, right.
Right. Yes. Huge security vulnerabilities like potential buffer overflows or SQL injection risks. And what's so critical here is that they can find certain kinds of code defects far more efficiently than dynamic testing ever could. A tool can examine every single logical path in a piece of code in seconds. A human would have to spend hours, maybe days, designing specific tests to try and exercise all those paths dynamically.
So static analysis isn't just about making the code look pretty or follow some style guide. It's about a kind of mathematical verification of the code's structure and its safety.
Precisely. And moving just a little bit further along that shift-left continuum, we get to test design and test implementation tools. These are the tools that help automate the initial creative phase.
Generating the testware itself, the tests, the data, all of it.
Yes. This category includes tools that can automatically generate test cases from a model or from a set of requirements. It includes tools that help you systematically create really complex test data and tools that help structure your test procedures.
Let's pause on the test data for a second because that feels really important.
It's critical. Imagine you need to test a new customer registration form. You need, say, 10,000 valid customer records and another 10,000 invalid records, each with a different kind of error. You do not want a human being sitting there typing those in.
No way.
A tool can ensure that the test data is varied, that it's realistic, and that it's created systematically to maximize coverage. And that dramatically increases the repeatability and consistency of your tests later on.
Okay, so now we hit the operational core. The part most people actually visualize when you say test automation. We're talking about tools for execution and measurement. This is where we shift from all the planning and prevention into actual dynamic testing.
This is where the rubber meets the road. So test execution tools are pretty straightforward. They automate the running of the tests, right? Whether it's unit, integration, system tests, they handle the setup, they run the scripts, record the outcomes, log the results.
Yes, but the crucial counterpart here, and you can't forget this, is the test coverage tools.
Right. We've talked about coverage as a concept before, but why is a tool so essential to measure it? Why can't a human just, I don't know, keep a spreadsheet and track it?
Because the level of detail, the sheer scale required for an objective measurement is just too complicated and massive for any manual effort. It's not feasible. A tool can do what's called instrumenting the code. It essentially inserts these invisible measurement points to track precisely which parts of the application's internal structure are being exercised by your tests.
And the syllabus calls out two key metrics here. Statement coverage and branch coverage. Can we just quickly define those? They're really core concepts.
Absolutely. Statement coverage is the simplest one. It just measures whether every single executable line of code has been run at least once during your testing.
So did my test touch this line? Yes or no?
Exactly. But branch coverage, which is also called decision coverage, is mathematically much more rigorous. It requires that every decision point in the code, think of an if statement or a while loop, has been evaluated to both its true and its false outcomes.
So for every fork in the road, you've gone down both paths.
You've gone down both paths, and that ensures that every logical path, every branch in the code is explored. A single if statement creates two paths. Imagine an application with millions of lines of code and thousands of those decision points. Tracking all those combinations is utterly impossible for a human, but it's a necessary measurement if you want to build real confidence that your testing was thorough.
That objective data is what transforms a subjective test report, yeah, I think we tested pretty well, into a verifiable, auditable quality measure. It tells you not just if the test passed, but how thoroughly the code was actually exercised.
Exactly. And speaking of measurements, that leads us right into the tests that are, frankly, difficult or just plain impossible to perform manually. And that's where non-functional testing tools come in.
Okay, give us the prime example. What is a test that you absolutely 100% require a tool for?
Performance efficiency and stress testing, no question. This involves simulating massive concurrent workloads. Just picture a major e-commerce site on Black Friday.
The big one.
You might need to simulate 50,000 simultaneous users, all logging in, browsing for products, and adding items to their carts within a very short period. A single human tester can only simulate one user. A tool can spin up thousands of virtual users from different locations, all meticulously tracking response times, system throughput, and resource utilization like CPU and memory. It's physically and economically impossible to do that without specialized tools.
And it's not just about speed, is it?
No, not at all. Non-functional testing isn't just about performance. These tools are also essential for testing other characteristics like reliability, how does the system recover from errors, maintainability, portability, how easy is it to move to a different environment, and of course, security automated penetration testing or vulnerability scanning.
So the lesson here is pretty clear. If the test requires either immense precision over a long time or just immense scale, a specialized tool isn't nice to have, it's mandatory.
It is mandatory. And that brings us to the final category, which is about how tooling has evolved to keep up with modern software delivery practices. We're talking about tools for modern development paradigms. These are essential for the ecosystems built around rapid, continuous delivery.
So now we're in the world of DevOps, where those old boundaries between development, testing, and operations have gotten really blurry.
Precisely. And DevOps tools are the ones that manage that entire end-to-end delivery pipeline. They handle workflow tracking, they automate the build processes, and they are the heart of continuous integration, or CI, and continuous delivery, or CD.
And CI/CD is all about automation, right?
It's nothing but automation. The idea is, every time a developer checks in new code, the system automatically builds the application, it runs a whole suite of automated component and integration tests, and it verifies that the new code is ready for deployment. This creates a constant, rapid feedback loop. It forces that shift-left mentality, ensuring quality gates are built into the pipeline, not just tacked on at the end as an afterthought.
That makes the process incredibly systematic. But people are still involved in all of this. How do the sources address the non-technical, the human side of tool support?
With collaboration tools, this is something people often forget. Testing is an inherently deeply collaborative activity. Testers are constantly interacting with developers, with business analysts, with product owners, with stakeholders. They're clarifying requirements, they're logging defects, they're debating priorities.
Right.
So tools that facilitate that communication, from integrated messaging platforms like Slack or Teams to version control systems like Git, They are essential components of the test ecosystem. And the source material even reminds us that a simple spreadsheet, when it's used effectively to track test status or manage requirements, it counts as a test tool in this context because it's facilitating an essential test activity.
And what about the environment itself? Because testing a constantly changing, unstable target is basically impossible. We need scalability and deployment standardization tools for that.
This is where things like virtual machines and especially containerization technologies like Docker or Kubernetes become absolutely indispensable. In a world of continuous delivery, you cannot afford to have a human manually configure a test server for every single test cycle. It's too slow and too error-prone.
Right.
These tools standardize the deployment. They create test environments that are stable, instantly reproducible, and crucially, they are reflective of the actual production environment. And that stability is absolutely vital, especially for things like system integration testing or non-functional tests, where even tiny variations in the environment can completely skew your results.
Wow, okay, that was a really deep and necessary dive into just the sheer volume and variety of tools that are out there.
Yeah.
It really hammers home that modern testing relies on an integrated technological ecosystem, not just a couple of scripts someone wrote. So let's pivot now to the big topic, automation itself. Here's where it gets really interesting, I think. Automation is so often sold as this panacea, a way to simply replace human testers. But the syllabus shows the strategic benefits are about transformation, not just replacement. So why automate?
I think we need to view automation as leveraging technology to handle the tasks that are sort of beneath the capacity of the human intellect. By doing that, you actually maximize human potential. You're taking all the repetitive, boring, and error-prone work, and you're delegating it to machines that are good at it.
Okay, let's start with the most intuitive benefit, the one everyone gets right away: quantifiable efficiency and speed.
This is all about time savings and repetition reduction. And you have to think about the specific tasks that automation just crushes. Executing those same regression tests every single week after every minor code change.
The worst.
The worst. Tediously re-entering massive amounts of test data perfectly every time. Or manually sifting through thousands of lines of log files to compare the expected outcome versus the actual outcome. Automation handles this repetitive load instantly, and it never gets tired or bored.
And the economic impact of that speed is massive. It's not just about a test finishing an hour faster.
No, it leads directly to faster feedback and time to market. The faster your test execution times, especially for those low-level, high-volume component and integration tests, the earlier you get defect detection. And when you find a defect closer to the moment it was introduced by a developer, it is dramatically cheaper and quicker to fix.
Because the code is still fresh in their mind.
It's fresh in their mind, exactly. This accelerated feedback loop is the absolute lifeblood of Agile and DevOps environments. It ensures that teams spend less time firefighting old, forgotten bugs and more time delivering new features. And the net result of all that is a significantly faster time to market for the entire product.
Okay, so moving beyond just raw speed, let's talk about how automation can inherently improve quality, consistency, and objectivity. How can a machine be qualitatively better at testing than an experienced human?
Through rigorous, unwavering precision. The key benefits here are consistency and repeatability. A human tester, no matter how skilled or experienced they are, is prone to simple errors when they're performing the same detailed steps for the 100th time. Maybe they skip a small configuration step, or they mistype a complex piece of data.
Sure, it's just human nature.
It is. Automation prevents these simple human errors. The tool ensures that the tests are executed in the exact same order, with the exact same data at the exact same frequency every single time. And that rigor is what makes the results reliable and comparable from one build to the next.
I see. So the consistency itself becomes a form of quality gain.
And that consistency allows for objective measurement. This is where automation provides objective assessment. We mentioned coverage metrics earlier. The tool can generate objective numeric data like we achieved 95% statement coverage or 80% branch coverage. These are hard numbers, and these are measures that are just too complex or too voluminous for humans to accurately determine on their own.
Right.
This objective data helps management scientifically assess the thoroughness of the testing effort, moving away from subjective declarations like, we feel pretty good about the quality.
But I think the truly strategic payoff, the one that really justifies the massive investment, seems to be what it allows the human to do. And that's elevating the tester role.
This is the biggest human benefit, without a doubt, and it's the one that connects right back to the core philosophy of what good testing is. By having the tools handle all the mechanical, repeatable tasks the human tester is given, as the syllabus says, more time to design new, deeper, and more effective tests.
So the automation is basically handling the assembly line of known checks, which frees up the tester for the more exploratory, strategic, and high-value work.
That is it, exactly. The tools handle the functional checking. The humans can then focus on the non-functional, the complex, and the non-obvious. They can dedicate their specialized knowledge, their critical thinking, their creativity, their deep domain expertise, and their analytical skills, all the things the source material highlights as essential human traits, to finding the truly subtle, systemic, or previously unforeseen defects that no automated script could ever anticipate.
So automation actually raises the intellectual bar for the human tester. They move from being, I don't know, button pushers to being quality strategists.
What's so fascinating here, though, and what the syllabus really takes pains to emphasize, is that this transformation, it isn't free, and it's certainly not guaranteed. If we only focus on the benefits, we fall right into the trap of unrealistic planning. The sources are very clear. Simply acquiring a tool does not guarantee success. You have to approach automation with your eyes wide open, fully aware of the significant risks and the non-trivial effort required to mitigate them.
That's a critical distinction. I like your analogy of automation tools being like a complex, specialized piece of factory equipment. It promises this massive throughput. But if you don't invest in the foundation, the specialized training, and the relentless maintenance, it won't just fail to deliver. It'll actually start producing faulty, misleading results.
100%.
So what are the major pitfalls that teams fall into?
Well, let's start with the mental and the financial hurdles. Financial and expectation pitfalls. The number one risk every single time is harboring unrealistic expectations.
The silver bullet myth.
The silver bullet myth, exactly. Organizations often buy into the marketing hype from a vendor, believing that this tool will solve all their quality problems instantly, or that it'll be incredibly easy for their existing, untrained staff to just pick up and use. This expectation gap is so dangerous because it prevents proper resource allocation right from the start.
And if the expectations are completely out of whack, then the financial budget is inevitably going to be wrong too.
Yeah.
That leads to inaccurate estimation.
Absolutely. The sources stress the risk of underestimating the time, the costs, and the effort required for three specific areas. First, just the initial introduction of the tool procurement, installation, configuration, initial training. That is often a major project all by itself.
Right.
Second, and this is often the most severe and the most overlooked, is the cost of maintenance of test scripts. In any kind of iterative development environment, the application you're testing is constantly changing. And test scripts are incredibly fragile. They decay rapidly. They require constant updating and refinement. Teams often budget maybe 20% of their effort for maintenance when, in reality, it might consume 60% or even more of the automation team's time.
So if the tests are brittle and they're constantly breaking, the whole team just loses trust in the automation system, right?
They lose all trust in it. The system turns from being this wonderful accelerator into a massive bottleneck. And the third thing teams underestimate is the effort needed to change the existing manual test process to actually accommodate the tool. You can't just slap automation on top of an existing, possibly chaotic manual process and expect it to work. The entire workflow has to be revised for systematic, repeatable input and output. And that requires training and, crucially, buy-in across the development and test teams.
Okay, so that covers the budget and time risks. What about the more strategic dangers of when and how we apply automation? What are the strategic and application risks?
The first risk here is just a straightforward misapplication of tools. This is using automation when a human-centric approach would be vastly superior. And the classic example of this is trying to automate exploratory testing.
Right.
Exploratory testing, by its very definition, relies on the tester's creativity, their rapid learning, and their ability to design tests on the fly based on what they're observing in the system. Trying to automate that removes the very human element, the critical thinking that makes it so effective in the first place. It just becomes a huge waste of time and resources.
So if we lean too heavily on the machine, we end up replacing strategic human analysis with systematic but potentially very shallow checking.
And that's the key psychological risk. ignoring critical thinking. If the big automation suite passes with all green check marks, the human tester can become complacent. They can start blindly trusting the tool's results and ignoring the need to challenge the underlying assumptions, or interpret ambiguous results, or look for defects that are outside the very narrow scope of the pre-programmed script.
The automation bias.
Exactly. Automation should assist, it should augment, it should elevate the intellectual work of testing. But it must never, ever replace the human tester's need for deep analysis.
That leads perfectly into the final category of risks, the dependencies we take on just by adopting third-party or open-source solutions. We're talking about external and technical dependencies.
And these risks are scary because they're often completely outside the team's direct control, which makes them pure project risks.
Right.
The first is dependency on vendor lock-in and support issues. The source material is very specific about what can go wrong here. The vendor might just go out of business. They might retire or sell the tool, which forces you into an expensive and time-consuming migration to something else. Or they might just provide consistently poor, support slow responses to your queries, inadequate fixes, or a lack of necessary upgrades for new platforms. If your entire test ecosystem depends on that one vendor, any of these issues can halt your project completely.
I often hear teams say, oh, we'll just use an open-source solution to avoid that vendor lock-in. Does that actually solve the problem?
It solves that specific problem, but it just introduces a whole new set of open source risks. The biggest danger with open source is that the project might just be abandoned by its community. If the core developers move on to other things, your test framework is effectively frozen in time. You lose all future updates, security patches, or compatibility fixes.
Yeah.
Furthermore, open source solutions often rely on a web of internal components that themselves require very frequent updates because the underlying technologies are always changing. This places a significant and ongoing maintenance burden on your internal team, a burden they might not have budgeted for when they chose the free tool.
So you're basically trading the risk of an external vendor failing you for the guarantee of an internal maintenance cost.
Precisely. You have to have dedicated, skilled automation engineers on your staff who understand not just the scripting language, but the deep architecture of the open source framework itself. And then finally, there are just strict compatibility and compliance risks. The tool has to be technically sound. It might be incompatible with the development platform. Maybe it doesn't support the latest version of your operating system or your browser or your programming framework.
And the really big one.
The really big one, especially in safety-critical or highly regulated industries, is the tool may not comply with the necessary regulatory requirements or safety standards. Using an uncertified tool to test, say, medical device software or an automotive system could be a catastrophic legal and safety mistake.
This has been an incredibly rigorous analysis of automation. It's just so clear that the rewards, the speed, the consistency, the objective metrics, they're massive, but they come with this hefty, non-negotiable price tag, dedicated resources for managing expectations, changing processes, and above all, that relentless script maintenance.
Right.
And failure to budget for that maintenance transforms the automation from a strategic asset into a crippling strategic liability.
That is the ultimate conclusion, I think. The success of test automation is fundamentally less about the tool's shiny features and far more about the strategic discipline that you apply to its introduction, its maintenance, and the crucial human oversight that prevents complacency. The tool is a powerful servant, but it's a terrible master.
This has been an incredibly thorough deep dive into Chapter 6, Test Tools. Let's just take a moment to consolidate the wealth of information we've extracted from the source material and the strategic insights we've derived.
Sure. We established that tools support the entire testing lifecycle, and we segmented them by function. We started with the management tools, like test management and bug cracking systems. They provide structure, auditability, and efficiency, and they're what allow teams to effectively report on progress and quality.
Then we moved to the shift-left tools. We had static testing tools, which includes everything from a simple spelling checker to a really complex code analyzer that finds structural defects early. And we had design and implementation tools that help generate systematic testware and crucial test data.
In the dynamic core, we talked about execution and coverage tools. They provide the automated power, giving us those objective measurements like statement and branch coverage data points that are, impossible to derive manually. We also noted that non-functional testing tools are absolutely essential for tests that require immense scale, like simulating thousands of users for a stress or performance efficiency test.
And finally, we wrapped up with the modern infrastructure. DevOps tools that support the CI/CD pipelines for continuous quality, and scalability tools like containers that ensure our test environments are stable and reproducible. And we can't forget the crucial collaboration tools that make sure the human communication around the whole effort is smooth and systematic.
And through it all, the core trade-off remains that duality of automation. It delivers huge benefits in consistency, speed, faster feedback, and objective measures. It allows testers to escape the tedium and spend their more valuable time designing new, deeper tests. It really elevates their role.
But, and it's a huge but, these benefits demand that strategic vigilance. We have to actively plan against the risks. Fighting those unrealistic expectations, budgeting accurately for the absolutely crushing burden of script maintenance and process change, avoiding the misapplication of automation to things like exploratory work, and continually guarding against the most insidious risk of all.
Which is the human tester relying too much on the tool and just abandoning their critical thinking responsibilities.
That brings us to our final thought for you to chew on as you move forward. We've established that automation is taking over the repeatable, the predictable, the systematic checks. The human's job is shifting, and shifting rapidly, from checking quality to designing the strategy around quality. So think about this. If every measurable, repeatable task is eventually automated, what specific, non-traditional skills, the skills that are fundamentally unautomatable and go way beyond just basic test script coding, what skills will the highly effective tester of tomorrow need to master to find the truly novel, complex, and systematic defects?
And the answer is woven throughout the source material, though it's often implicit. It's creativity, it's deep domain knowledge, and it's high-level analytical thinking. The highly effective tester of the future must master the abstract, the philosophical, and the creative aspects of quality assurance, because those are the uniquely human capabilities that no tool, no matter how sophisticated it gets, can ever hope to replace.
A profound thought to end on. You have the tools, you understand the risks. Now go forth, plan realistically, and keep digging for knowledge. We'll see you next time on The Deep Dive.